Done.
Hello, everyone. Again, welcome to the American Council of Independent Laboratories webinar series on electromagnetic compatibility. What I have in front of you is the general announcement for the year of topics that I will be covering and have covered. I'll scroll down and you can see that we've already had 3 of the 6 concluded. One earlier this month on the ANSI Accredited Standards Committee C63 on EMC, and today we're going to be reviewing a very important advisory committee in the IEC, International Electrotechnical Commission, on EMC. It's called the Advisory Committee on EMC, ACEC. I chair that group, and I just got a 6-year extension, so I'll be doing this webinar probably on a continuing basis throughout the subsequent years that this is going. You can see further that we have 2 other webinars. I'm going to take a break mainly because the idea of I'm trying to follow up on current meetings that I think are important, and there is a break in the action until October when CISPR meets in Frankfurt, Germany, and I will pick that up on the 16th of November because I have other commitments. And then there's another advisory committee meeting which is going to be held, well, we haven't decided where it's going to be held at the moment, but it will be in November. And that will then conclude the series for the year. I will then put together dates for next year and maybe pick up another committee that's important to cover in electromagnetic compatibility. So this is a general announcement, and there's other information there which I don't think we have to go into. So keep this, if you can, in a file somewhere, and you'll know the dates. All right, so what I'd like to do then is get started on the topic that shows there for the 21st of June, which is review the International Electrotechnical Commission Advisory Committee on EMC meeting, which is, as I just mentioned, a major advisory committee for all the technical committees in the IEC on that have electromagnetic compatibility as part of their work. That's in addition to the standard CISPR and TC77 work, which I'm going to show some background on. So let me close this down and bring up the agenda, which was at the last meeting. And you can see it's only less than 3 weeks ago. And these are full 2-day meetings, so we cover some 30 subjects, 30 presentations, or not all of them have presentations. So what I propose to do is, as I have in the past webinars, is go through the agenda and not dwell on things that is not of interest, but focus more on what was presented on EMC. So as we go through as I scroll through here, you'll see there's a lot of administrative overhead. We have invited several technical committees that have EMC to join, and I have the ability as chair to bring in anyone as a guest as needed, but I prefer to have someone that's responsible that we can count on being there. So agenda item 3 is the membership. Maybe I'll just open the 408 document so you get and make it a little bigger so anyone can see it. And you go to page 2, which is coming up. This is the who's who in our committee. There's myself as chair. I have a vice chair, the University of Tokyo. The technical officer, the secretary is from Geneva, Lorraine Mallet. Then we have representatives from many committees, which I'm going to go into their presentations. Emmanuel Dieger is 77A, which is low frequency EMC, which is generally the 61003-2 and 3-12 activity. 69 is electric vehicles, and I don't propose to go through the whole list, but we did pick up someone from TC22, which is on grid-connected power inverters, and that's why it's highlighted in yellow. He had his first meeting with us in May last month. Mr. Helmy has joined, but we didn't get his photograph in on time, but he represents 46, which is cabling and connectors. 77C is high power transients. Look at that as like electromagnetic pulses from a nuclear burst, for example. And then we have others appointed, and the one that is also new is Ms. Ni from the China Electric Power Research Institute. She has wonderful credentials, and unfortunately she could not come to her first meeting, which was 3 weeks ago. And then 77B, which is the class of 61004-X series, which I'll talk about the status in a moment. And we have a person from South Africa, or Africa. This is Ade Algonzola. He is from Nigeria, although his office is in Abu Dhabi. We have had meetings there at his office. Bernd Schultz, TC13, they're on metrology meters. Bob Sitzman, which is Technical Committee 62, which is medical electronics, including EMC on the classical 60601-1-2, which I'll talk about because that's been shaken up, where EMC is now a separate document. Subcommittee A on measurement instrumentation and methods in CISPR for emission measurements. And then Mr. Wu, well, it's still Mr. Wu. He has stepped down, but we kept him on this list. So there is the main people, and when I go through the rest of the agenda, you'll see that we've added several other TCs, and we, of course, then will update this information. So that's all I wanted to talk about is where the members are. You'll notice that they're represented from 6 continents, 5 continents, not the 6th one. We don't have any from Antarctica, and from a very diverse group from the Far East to Africa to Europe to the United States and so forth. Which is in the office, they all have excellent English, which is, of course, the language of the meeting. So I'm going to go past the membership. One of the things we do is review the minutes of the previous meeting, which I held in Boston in November. It turns out the IEC has an office in the Boston area. It's not close in. In fact, it's almost an hour's drive outside of Boston. But nonetheless, the IEC put in one of their local offices in several places. They have one in Africa now, and they have one in Singapore, for example. But the one in the U.S. is largely covering those technical committees in which the U.S. has a secretariat or a secretary. And so it makes sense to be a little closer to service that particular group of people. Don't want to open up those documents. I'm just going to go into a little bit about the SMB, which is called the Standardization Management Board. These are the people, there's 15 members. They manage the entire IEC technical activity. And it turns out that ACEC is a advisory committee directly to them. That puts us even above the technical committees in closeness to the technical management of the IEC. There's one on safety, there's the one I am on EMC and so forth. There's even one now on robotics. That's a new one that just started up about 4 or 5 months ago. So let me just open a few things here. There's And I'm going to have to be selective because we only have an hour, because this agenda took 16 hours to go through. We always we have the ability to ask the standardization board for information, and they give a report back. The one I just brought up is the one that extended my term, which was approved. And then I gave a presentation to the SMB in February. I'm going to show a couple slides of that later on. And one of the things I was punctuating was extending our reach to help other technical committees. They have EMC, and you can see by the second highlighted area there, it was meant by the second one was ACEC. They forgot the E. And they were very appreciative. And by the way, TC 106 is human exposure, and we also have a good relationship and liaison with those folks that do human exposure. In fact, from the U.S. perspective, I'm the head of delegation to that technical committee. Okay, so I'm going to close that down. There's other documents that I'm just going to be somewhat selective here because we need to keep track of our parent organization. That's why we spend time going over SMB documents. And this is a list of decisions made at the meeting which is held in February. This is the meeting that I gave my presentation in Geneva. And you can see there's a bunch of decisions. I don't propose to go through them. But this is decision 3 I'm showing on directives. Decision 4 on the joint tests, joint technical committee at JTC 1. And the interesting thing is you notice that the comments are very short, and to further, somewhat amusing to me, they are written in advance of the meeting, and what happens at the meeting, if there's a vote taken or a discussion, it's either to confirm what is there, what is prepared, or if there's changes, then there's in real time it's changed. The bottom line is that the actions that are taken by the SMB throughout the meeting are instantaneously shown on the screen to all members before they go on to the next agenda item. So everything you see here was on a screen. And talk about real-time activity, huh? And for example, in my ACEC report, I was thanked for giving it and complimented for us reaching out to the TCs. Normally, I would go through and see if there's any others, and I'm just scrolling fast, so don't let that bother you at the moment. But it turns out that at this particular meeting, there was few. Let me just go to the end and see how many. See, there's 35 decisions made this meeting. And this meeting is a full day. But 35 things are done. Now, the reason why you can get to that number is, as I already mentioned, a lot of the draft decisions have been prepared in advance. So let me close this then. All right. I don't think there's anything else I want to talk about the SMB. And now we get into the heart of the webinar. There's about 20 reports here, and I have to be selective because we already are 15 minutes into the hour. But I think I'm going to at least report some of the major ones. Well, I'll start off, you can see we start off with CISPR and 77 because they are the 2 technical committees that deal with EMC. And they are then look for basic instructions from the other TCs. So let me just bring up one of the talks I gave. And let's see, let's make this full screen here. I always go through, who our membership is, and one of the things interesting, we are more than just the national committees. All the other technical committees are run by their national committees, which could be 25 to 30 to even more countries that are active. Well, we have the same thing, except we have all these others that we are liaison members, and that's what makes CISPR the Special International Committee on Radio Interference. The special part is that we have our own makeup, and the purpose of that was way back in the 1930s is that we are protecting radio spectrum, and therefore we need as much input as we can get on the users. And you can see, for example, we have the European Broadcaster Unit. There we have the amateurs and the ITU people as well. And we do have some local stuff. We have representation from ACEC and ECMA International. We used to be called the European Computer Manufacturers Association, but now it's just called ECMA International. Then I give a very short view of what we've done, and let me go right to the recent activity that I talked more about. We are very much concerned of setting limits for emissions in the frequency range 9 kilohertz, 750 kilohertz. And why is that important? Well, that turns out that's where the power line communication is for controlling smart grid devices on the mains, on the power line. So there's a concern there that that signal has to get through unperturbed. But on the other hand, all the power inverters and the grid-connected power inverters, namely the brick you have serving your PC, for example, is putting out emissions in that frequency range. It's above just 50 or 60 hertz, all the harmonics. And they have to work compatibly, if I can use that word. So there's a lot of action on what should be the limits, and how do you measure these? Should be a conductive measurement, or should be a radiated measurement, like a radiated magnetic field measurement? And that argument is going on, and research is what's the best going on. Then we discuss wireless power transfer with the International Telecommunication Union, the radio sector. And of course, if it's a ISM frequency, it's unlimited on the fundamental emissions. Therefore, obviously, if we have to do wireless power transfer and it's high energy, like say for charging an electric vehicle, it would be nice if we could choose the ISM frequencies, but there aren't that many frequencies available. So that's a nice thought, but not necessarily a good option. And I think that's, I'm getting a very interesting buzz. I'm not sure what that is. Hopefully it goes away. One thing I want to point out, and then I'll close this. Wireless power transfer is in we look at 4 different ways. Most of the people think it's inductive, one coil transferring energy to another coil, much like a transformer action. But we also have capacitive power transfer. We have it in the microwave power transfer, and we have infrared power transfer. So we are very careful in using WPT as the generic, but when we get down to inductive power transfer, we actually call it inductive power transfer, or IPT. I thought this was an excellent graphic here to show you all. Okay, I think I'll close that one and go on to a couple, well, just continue on as we go through the morning. This one is Subcommittee A, which is the basic standards for measurement instrumentation and measurement methods. Let's bring this up here. Okay, make this bigger. You can see that it goes beyond just the 2 I mentioned, but it also does uncertainty, and it has some other joint work with 77B on TEM technology, reverberation, and fully absorbed line room measurement methods and arrangements. This is very detailed, and I don't propose to go into in that detail, but just looking at something from working groups in working group 1, which is the instrumentation one. You can see there's a lot of work on coupling devices. There's work on chamber validation still going on. There's concern with the site validation for equipment that has that is high and as taller than 2 meters, because the site validation goes up to 2 meters, and it says if you test something that has part of it above 2 meters, you can't do that test. Well, obviously we don't want that, and people have been doing tests even up to large screen displays at 3 meters tall. There's maintenance work there at the bottom. There's work on artificial mains network and probe calibrations and so forth. And anytime that we introduce something new, we have to have an uncertainty budget that follows it. And again, I'm just continuing on here. Going on to working group 2, this is the measurement method group. And how do you use a delta network or a voltage probe, for example, is being worked on. Another thing comes up on the equipment size. Is there a separation distance that is the minimum, depending on equipment size, the width and the height? And the answer is there is, and that's being discussed. The LLAS is the large loop antenna system. This is up to 4 meter in diameter, 3 orthogonal magnetic loops, and you put the product inside that and you measure all 3 axes, and therefore can get an idea of the radiated power from an emission perspective. Working on hybrids, sounds like a familiar statement, huh? And this one down here on work below 30 megahertz, even though it says later, there's still a lot of activity. And with that, how do you measure below 150 kilohertz, which typically there's been no limit and no measurement method, but there is some, for example, induction cooking is measured below 150 kilohertz and has limits for that particular product. So the question is, what do we do in subcommittee A? There's joint task forces with 77, as I already mentioned, and 77B in particular, and you can see the TEM activity and also the reverberation activity. And I'll talk about these a little bit later on when I give the 77 presentation. Then we have intra subcommittee work in SISTRA itself, which I think is of limited information we need for this webinar. So the last slide of all the presenters, I asked them to say what do they want from ACEC, and you can see here the answer is nothing at this time. Okay, let me close that down, and let's bring up the I guess the H report. This is the generic emission standards. If a limit is not captured in the product standard, you have to use the generics. Wait, I must have pulled up the wrong one. Let me get back to H. Yeah, I did. We do document 19. Okay, let me make that full screen. Now, there's a lot of detail here, but you can just see from the title, these are the generic limits that if there are no specific limits, like, for example, information technology equipment or industrial, scientific, and medical, etc., in the product-specific standard, then you have to revert back to what's showing here. And I'm just going to go through the titles because I gave this because the chair wasn't there. But the 2 generic standards we're talking about for residential and industrial are 6-3 and 6-4. And the reason why it's not a CISPR document, it was meant to be a complementary document to 61,000-6-1 and -2, which is the immunity generic suggestions. So that's how it ended up being a 61,000 document. ISR revisions, we're always struggling with definition of environments. What's the difference between residential, commercial, light industry, industrial, and the list goes on. The good news is that we still are going to be working with 2 sets of emission limits a limit for those particular environments, mainly because it's hard to identify what is different from a residential and commercial or light industrial. For example, you could have a telephone switch, or at least a subscriber terminal sitting in front of a residential environment. Well, is that commercial or is that residential? And the arguments continue. They're working on limits for fully anechoic rooms, so-called FARs, and they are looking at also what to do in the below 150 kilohertz. Again, I won't go through all these details, but you can see there's a lot of work trying to see the classifications, which is what, 1, 2, 3, fourth column over for emission. And you can see, depending on the subject in the first column, there's either 2 classifications or not, and some of it for the ISM is based on connecting to the mains, the low voltage mains, and it has nothing to do with residential or commercial or light industrial, which is quite different than CISPR 32 or multimedia, which is based on a residential environment being something within 3 meters away, and a Class A being 10 meters away. Complaint statistics they get into. Models for photovoltaics, and extra low voltage. Photovoltaics has some issues with interference potential. And I just don't have time to go into that right now, but it's on our radar screen. CISPR 31 is the list of radio services, and it was void of services below 150 kilohertz. We now have entered what is there in the ITU-R, and largely has to do with clock frequencies, setting your clock with WWV, for example, or radio navigation services. And these are protected because we consider them radio services, so it's under the responsibility of CISPR. And I'm going to continue on. The in-house lighting system, by the way, is a concern with replacing an incandescent with a LED. They generate noise because the way in which the lighting is, the lighting voltage is presented to the LED. And I'm just going to go in here. Again, it's informative. Let me close this down. Okay, escape. And get back to let me close this down altogether. Now I'm going to bring up, we're going to shift over to 77 on EMC, and I'll give the 77 report, and then I'm going to spend a little time on the subcommittee B, but I would like to at least start off with the parent committee information. And Hiroyuki Osaki is the chair. He's also the vice chair of ACEC. I wanted a vice chair in case I can't make it, or although I've made everything for years, but it's always good to have a backup. And I put him in charge of the young professionals activity of those young professionals that want to get involved with the EMC. And I'll talk about that in a moment. So there's the 3 subcommittees. Subcommittee A is low frequency EMC. Subcommittee B is high frequency. And 77C is high energy, high power transients. By the way, the break frequency between low and high is sort of a smear. Generally, it's considered roughly around 100 kilohertz. And for those people that are in the power system, they say 100 kilohertz. Well, that's RF. And those in RF said, well, that's DC. So it's an interesting discussion. A lot of information on present documentation. Working Group 13 is one of the most active working groups. And you can see that they're involved mainly with definitions and environments and other guidelines. They're not into the test scenarios. The last meeting was in Santa Barbara, which I attended and represented CISPR there because we have a close relationship with 77. Then this is sort of the explanation. I would draw your attention to the second one at the bottom, 2-5. This is first published a while back, and then they updated it in 2015, and find now that they tried to update it in 2015, and they're at the CD stage, which is the committee draft. And I don't know if I'm sure that the closing dates occurred already in May. But the idea is that it's the application and interpretation of fundamental definitions and terms. And the fundamental definitions is very important, especially if you're talking about environments that are different from industrial, in residential, and so forth. I won't talk too much on these. There's things on, as you can see. By the way, a TR means a technical report. That means it's not normative, but it's published for information, and if you use it, you use it. And you can see in that first one on overview of the 61,000 series, I like that document, by the way, because it gets you an idea of when you apply a particular 77B standard, whether it's on immunity, and it gives the standards that apply to bursts, transients, surge, and so forth. And it was an international standard. IEC is an international standard, but because it doesn't have specifications, but it's just guidance on how to use documents, they moved it over to a technical report. All that being said, this is a very important document. You can see it's right now at the technical report approval stage, and with 96.8% in favor, it's clearly going to be published soon. Okay, let me continue on here. Already talked about the generics. 6-1 is residential, commercial, light industrial, and -2 is industrial. Let's see if there's anything else I want to talk about here. I think I prefer to go into the subcommittees at this point, so let me do that. So let me escape and close this out. And we'll bring up subcommittee A, which is working this issue with what to do with the power line communications and the emissions coming out of power supplies, AC/DC converters. So they have working group 8 is what he focused on here, and that's important. If you look at the heading up here, compatibility levels between 2 and 150 kilohertz. And compatibility is, as I just mentioned, that power line communications can work in the presence of the noise that's generated from AC/DC converters. And why power line communication is important, that's the way in Europe in particular they control smart grid and the metering, the two-way directional information that flows on the smart meter. So it is beyond just trying to get something that is reasonable for a particular single application. The good news is the two red items there, that the working group 8 has brought in, they must have 30 or 40 members of that committee, and they brought in representatives from technical committees that are concerned. And the meter people are TC13, and the grid connector power inverter people are TC22, and they're clearly present. And so between 2 and 30 kilohertz, they actually came up with an agreement of what that compatibility level should be. And obviously you have to have a little bit more immunity for the PLT, and you have to have a little less emissions. But the point is, can you imagine having to, at this point, go out with the billions of electronics that have AC/DC converters and put in a filter? That just didn't make any sense. So this is going forward. And we already found this interesting note. It was reported that the filters that would be used for that have a life expectancy of 15 years. 15 years. So if you look at that, even if you tried to put filters on everything, in 15 years, if that's still in service, you have to come back and change it. So, you know, there's economic consequences here as well. And since the power line communications is about 80, 85 kilohertz, there is a disagreement on what that limit should be for that kind of communications. And therefore, the 30 to 150 is still a bone of contention right now. And so there's a lot of decisions that were made. I don't know if we have to keep going. If you look at that second bullet item, that under consideration for 30 to 150 has gone beyond that now. They've actually have a document for comment out to the national committees. They have come back, and the unfortunate, and let me go back. The unfortunate part, maybe I'm saying that later on anyhow, the national committees were split on how to proceed with a compatibility limit above 30 kilohertz. And if you look at this chart here, a little busy, but looking at the 30 kilohertz, the option A and B, you can see the difference between A and B, let's say at 50 kilohertz, is what, 20 plus dB. So, you know, it's not just 2 or 3 dB here or there. So you can see why there's a not agreement of whether it should be the emphasis placed on controlling the PLT or an emphasis controlling the emissions from the grid-connected power inverters. So this is a very illustrative graph of the big difference between option A and option B. And the national committees couldn't come to a consensus. So Working Group 8 has a lot of meetings scheduled and webinars in between, and I don't think there's any need to go further. Well, this is kind of the count of that vote of about 30 kilohertz. You can look at 25 national committees expressed their opinion. 7 said choose A, 8 says choose B, and 10 said I got another idea. So clearly there's no consensus reached, and right now that is the struggle to try to come to a compatibility levels consensus. So I'm just looking here if there's anything I want to point out. So the action is to move forward with try to come up with a second try at this. And you can see the timelines are below. A second CD release a year from now, or at least 6 months. That's a long time. And what they're saying by that timeline target is it's going to take a while for that frequency range. And I think it's a fair estimate. So there's other things that are being proposed, but even doing a cost analysis and even looking at the alternate proposals. So if you want to be on a very active committee, these folks have it in spades. So right now the summary is there's agreement between 2 and 30 kilohertz and not an agreement at all between 30 and 150. And I'm just going to go past these other projects right now. There's work, of course, on 70CA, but Working Group 8 is what we just talked about, and Luc Berthet is the convener from France. And they always ask for advice, and our advice is keep plugging away. We got to have an answer. And by the way, there are some smart grid installations that use power line carrier that are, let me say this, they're not up to full potential in controlling the smart grid, which of course is the goal of all this. All right, let's go to B, which I think would be of interest to most, and then I'm going to start skipping a little bit. Not there. I think there is one there. Let me just see. I may not put the link there. If not, I'll come back to it. There, here it is. I didn't put the hyperlink in, but I'm doing it right now. This Luis Nino is the chair. Let me make this full screen again. And the activities are in Working Group 10 and Maintenance Team 12. Working Group 10 is what most of us are familiar with. Maintenance Team 12 is the high power transient testing. And they work with other subcommittees. New publications since the last time, the 4-3 on radiated electric field immunity testing. The stability date, which means before that, the document, the last edition, could not be changed until 2016. And it turns out that there's a committee draft under preparation for the next edition, but it hasn't happened yet. On 4-6 on conducted, it can go to 2018, so there's no work scheduled because they have enough to do on their plate. So you don't have to worry about any lab assessments for changes in 4-6 because it will remain what it is until 2018. 4-39, the second one there, I'll just point out, there is now a committee draft or vote, that's what CDV stands for, on testing in close proximity to the equipment under test, less than a meter, for example. And this is very useful to, just to give you an idea, and the medical folks, they are very interested in this because there are people that use their mobile phones, literally centimeters away from external medical monitoring devices, and they have to, of course, still work, and therefore this 4-39 test is there. A lot of people are looking forward to beyond just 77. 4-2, the ESD, it's stable until 2017. So right now they're doing just collecting items that might be considered for the committee draft starting next year. The burst is even further out, 2018, again in the collection mode. So again, from the lab assessment perspective, you don't have to worry about having the latest versions of these standards because what you have now is still going to be current through 2017 and 2018. The SIRS is this, it could be changed to this year, but they're still collecting what they want to change. So when you're in the area of collecting items like that, you're still probably 2 years away from a real change coming out. Magnetic field, well, these are specialized tests. I don't think I want to go through 410 and 412 as well as 418. And the joint task forces are moving on. TEM is 4-20, and the stability date is this year. They wanted to get a CD out last year, but the review report, RR, said it could not be done, so the schedule is really uncertain. So I don't look for much happening in 4-20 to come up with edition 3. Going over to the Joint Task Force and reverberation, you can see the stability is this year, but they are at least to the point of coming up with a committee draft. Notice it says committee draft 1. What that says to me is they expect to have more than one because of the controversy that might ensue. And I think that's all I want to talk about there. And let me close this for a minute. Let's see what else I want to pull up. I don't want to go into C right now. I want to just pick and choose now because you can see there's a lot of documents there. 13 and 22, I've talked about. 13 is the metrology people, the meter people, and they're worried about smart grid communication with their meters. 22 is the people that worry about the grid connected power inverters. And right now, between 2 kilohertz and 150 kilohertz, they have published what is typically on the power line, the mains, from presently installed base. And when you look at those numbers, this is what's out there right now. And then when the TC13 look at that and said, well, wait a minute, that's pretty high, and we certainly don't want to have more of those. Well, you can see now where the issue of trying to come up with a compatibility between those two requirements. 46 is kind of an interesting, this is our cabling. Let me just bring it up for titles. And unfortunately, you didn't put PowerPoint together on it, but if we start looking at the titles, and I'm going to look at status of documents. There's a bunch of I'm just going to pick out a few, because we'd be there forever. He's a new member, by the way, so he came loaded for the meeting. And why is that jumping like that? Okay, there's an introduction to screening effectiveness, shielding effectiveness. So they're into that for sure. Then they're worried about the cable test methods up to 3 gigahertz using a triaxial method, which is a special test fixture. And it says up to and above 3 gigahertz, and I challenged that at the meeting saying, above 3 gigahertz is 300 gigahertz. Do you really want to go up to 300 gigahertz? And so they took under advisement that what they meant is around 3 gigahertz, 2.5 to 3.5. And I said, well, it's very misleading when you say above. So hopefully they'll get that straightened out. Then there's the absorbing clamp method where you're measuring the current transferred from the inner conductor to the outer. And that's part of the transfer impedance test, which is in 4-7. Capacitive coupling. I'm just sort of searching here if there's anything that show this. They're also in connectors, and you can see on 4-10 it also handles attenuation of feed-throughs and gaskets and so forth. So almost anything to do with cabling, and the interest for EMC perspectives, of course, is that if there needs to be a shielded environment or a very good twisted pair environment, could be twisted pair shielded, and so forth, we ought to know what's happening in 46. And that's why I invited 46 to be a member of ACEC. I think I'm going to pretty much stop here because, again, the list goes on, and I don't think I found anything that I want to talk about for this webinar because we have other things to talk about. So let me close that. I think you got the idea what's in 46. Excuse me. 61 is an interesting group. I may just show the titles of these as we go on here. 61 is household and similar electrical appliances, safety, but there is an EMC need because EMC and the product doesn't act as it should, may become a safety issue. So this report was very short. He just was introducing it to one of the documents they're working on right now, and it's they're using immunity tests that were recommended. And I look at the next view graph. They split up what level level 3 is higher than level 2, obviously, and they split it up into those frequency ranges. So you got the typical 80 to 1,000 radiated tests, and then between 1.4 and 2 gigs and 2 and 2.7. So I thought that was kind of interesting how they split up the frequency ranges. Okay, let's move to 62. There's one thing I wanted to point out for sure in 62 is what happened to the EMC work. And we're getting close to the end. This is Bob Sitzman from Siemens. Let's make it full screen first. So the classic case was 60601-1-2, and they had an EMC section, a collateral standard. And what happened is it was published, as you can see, in 2014, and they're working on the next edition. But the stability is not until 2019, so that document is going to be around a while if you're measuring or testing to it. But there is an Annex J in that document, which is shown, which is identified here. And what's happened is there is now going to be a new technical report, 60601-4-2, and it will have all the EMC stuff that was in the 60601-1-2, which is a safety standard, pulled into 4-2. So this is the document that you really will have to get a hold of for EMC application, because even though it's just the contents of J, my guess is there will be things added to it. And you can see the result of the vote was 75% in favor, which means it passed. So it's in the pre-publication stage, and I expect it to be on the street by August. So 60601-4-2 is a standard, is a technical report that should be purchased. And these are just the timelines, and I don't think there's anything there. And these are just what the subcommittees handle. 62A is what we're talking about, common aspects. Then they have diagnostic imaging, and B, radiotherapy, and C, and general electromedical in D. So that's all I have time to talk about in 62. And let's do 69. That's electric vehicles. And that's document 2. And the big issue here, as you might imagine, charging on board the vehicle or charging at a charge station, because the requirements are different. So I'm just sort of scroll through here. So here's the one off-board. Off-board means it's a charging station. You see it's on the 4th CD. That means 4 times they tried to get what they needed, but they ended up being successful to go to a voting document, which is CD, committee draft for vote. And I expect it's any moment, or it may be on the street already. Then you just went through a couple of the standards and just look at the titles. General requirements for electric vehicles, AC and DC conductive power, light electric vehicles, conductive power supply requirements, and so forth. And here is wireless power transfer, because the charging administration can be done wirelessly as well as someone flipping a switch or plugging in a cable, and things start automatically. So edition 1 was published last year, and I get the sense that he wasn't at the meeting. I gave this for him, that this might be coming up fairly quickly. So let me close 62. Let's bring up 69. Oh, I did 69, sorry. 106, this is the human exposure, and I am the representative for CISPR on human exposure. And full screen. The only thing I want to maybe point to here, let me go to, they work entirely by project teams, PTs and maintenance teams. There's no working groups, which is kind of unusual. If you look on the far right there, the ad hoc group number 6, the convener is Jafar, and he is working on a guide on how to do human exposure measurements. And you can see, though, in their program of work, wireless power transfer they're scheduled to get a report out by 2017. Body warm devices, anywhere in the body, and people are wearing things on their belt, they're wearing things close to their chest, and so forth. So there's interesting. I just highlighted in red here, this is the guide they're developing, and I expect to get something out in 2016. It identifies, you can read yourself, requirements and gaps for EMF guide on developing consistent and quality standards for assessing human exposure. GC 106 does not set limits. They cannot do that by decree. And there's a lot of things going on here with computational measurements, the measurement where you actually have a human model that you put brain simulation solution into and measure the penetration of a signal from let's say, mobile phone. And they're working on problems with transmission from a vehicle antenna, both mounted internally or externally. And then they get into computational electromagnetics, the finite difference. finite element, finite difference. I've already talked about the wireless power transfer. And this is the guide. The interesting thing about the guide, if you look at the bottom bullet, the ownership, guides can only be produced by advisory committees. So ACEC has agreed to take that action to administer it, but the maintenance of the technical stuff comes out of 106. Let me close that and see what's left I can talk about in the time we have left. Maybe of interest. At every meeting, I also give a report on what's happening in the EMC Society standards, which everyone enjoys because I give them, you can get in talking about, anyone can join, and if I go to, I give you the list of all the standards we have, which is on the EMC Society website. Don't want to go through that, but the last thing I do at the end here is the green items there. It's open for more IEC activity, and I always encourage ACEC members or their colleagues to participate because this is all done electronically, so there's no travel involved, so it's just a matter of time. So that's something that's given. We worked in young professionals. Let's see, which one do I want to bring up? And let me see if that's the one. Yeah, it's hard to read, but this is a questionnaire we put together because at the IEC general meeting every year, the national committees name young professionals they think are up and coming. So we put together this questionnaire if they have indicated on their write-up they're interested in EMC. And then we ask questions, what are you most interested in? What IEC committees are of most interest to you from an EMC perspective? So this is gaining some ground. We've got about 4 or 5 that have leaned heavily towards working in the IEC on EMC, and we're getting them to be in contact with their national committees so they can join a working group in CISPR or GC77, for example. So I don't have time to go through the whole list, but I just wanted to alert you that ACEC is heavily involved in the work here. And we're just coming to the end here. Let me just see what else I could talk about. Future conferences, there's a link that we have that when you bring it up, it's on the IEC webpage, and it shows the links to current upcoming international EMC standards, EMC meetings, not just standards. And so we highlight that, and when you click on these buttons, you get to the home page of that. And we update that about every 3 months. I just wanted to point that out to you. So maybe the last thing I'll do before I close is on the IEC website, there is an introduction to electromagnetic compatibility. And it is, what I did is I took all the information on the website and put it into PowerPoint. And you can see all the people that have commented on it in the last two months or more. And the thing I like about it, this was meant to be those that have been just introduced to EMC to even know what EMC stands for. So you can see that the part of this, it would be to, let's say, your customer that, what's EMC? What are we talking about with tests? Well, this document, this PowerPoint, which hopefully will be posted on the IEC webpage so everyone can have at it, can be used as a history or a background of what we are talking about. In fact, to be quite honest with you, I used this on my parents, and at least they knew what EMC stood for. And it goes on and on. There's 59 slides here because that website on the IEC is quite extensive. And we talk about disturbances, the difference between disturbance and interference. And then here in simple terms, the EMC describes the ability, and you can read that yourself, which you're all familiar with. And it concerns us all. These are headings that are from the website that we talk about emissions and immunity, the types of disturbances, which I just talked about in 77B. And it goes on, and I think, again, I'll close with that, because I think it's good background, and this is one of my ideas I wanted done this year, and it looks like it's going to happen. It'll show up on the website. So I kind of rushed you through a little bit, but not really, because I was pointing out the highlights of all the presentation, not all, but what I thought was major for the webinar. Our next webinar for this committee is end of August. We're meeting in Frankfurt at the IEC General Meeting in first week of October. And I have a webinar. We have webinars every 3 months. We have webinars between the 2 annual meetings. Therefore, it's midway, so it's 3 months after a meeting or 3 months before the next meeting. And we're looking for someone to host us in May of 2017. And just for your information, I asked the U.S. National Committee if we could hold that meeting in the United States. So with that, I think I will close the webinar, and hopefully you've got a better sense not only of ACEC, but of all the technical committees that I was able to give a little bit of information on that are doing the standardization that you folks in the testing business have to follow at some point in time. So, and also I gave you a sense of which will be stable for a while. And I also gave you an indication of something you may need to purchase fairly quickly if you want to. Again, when you're audited, the assessor always asks, are you sure you have the latest version, which is the 17025 issue. So with that, I close the meeting and thank all for participating. And at this point, we'll turn off the recording, and these are available, will be available on the ACIO website as a ability to look at it.